Hi guys, welcome to the fourth lecture of our NLP series. And guys, today we'll be talking about naive Bayes classifier. And guys, we won't be spending a lot of time on these type of lectures. As you know, I've been very candidly saying you that mostly all NLP workloads are now leaned towards LLM. And yes guys, LLMs are doing a great job, so we need to get our basics right so that we can quickly move towards building great NLP projects which use LLM in all sense, and those are going to be very interesting. But these are the basics, guys. Basics helps you crack interview. Basic helps you understand transition from statistical models to large language models, and guys, that's the core of it. So guys, today we'll be talking about a simple use case. Let's say you're having emails and you wish to classify it into spam and ham. So simply you want to classify your emails into spam. That means they have some stuff which you don't want to read, and ham is essentially your important email. So guys, in these type of use cases, a lot of people use name bias. As I said guys, now in production ready workloads and performance of LLM will be unmatched, so it's okay. But still you need to understand the maths behind it, and it's very simple guys. It's simply fully based on probability, and it won't be very difficult. We'll be covering it quickly with a very common and very used example. So guys, first of all, what happens is you would have something known as training data, right? So what is training data? Training data is the data set that's given to you. Okay, that would have two columns. Right now we are talking about supervised learning. Okay, we'll have two columns. One would be text and the other one would be label. Okay, nowadays guys, a lot of people skip this part of supervised learning. They simply go to unsupervised learning, that is directly roll out an LLM to do these tasks. But guys, we are focusing on the basics, so let's just stick to it. So we have training data. We'll split our training data into two sections, spam and ham. Okay, that's part one of the game. So guys, the first step is create a data set for ham messages. That means create a data set for messages which are not spam. So guys, then whichever word that occurs in your data set, right, you need to create a frequency count. So dare occurs 8 times, friend occurs 5 times, lunch occurs 3 times, and money occurs 1 times. This is okay guys, very basic. So whatever would be the frequency in the training data, we just need to write it down. And obviously guys, this is a dummy example. Then you need to compute this 8 by 12. What is this 8 by 12 guys? This 8 by 12 is essentially number of normal messages which you have received divided by the total messages. Okay, so messages are essentially normal plus spam. So assume that you have, out of 12 emails that you received, 8 were normal and 4 were spam. Okay, you need to compute this as well, so you are able to do it. See guys, this is basic probability. Now the next thing is guys, dear normal. So what is this? So we are computing the probability of dear, given that it is coming from a normal set, that means from a ham set of data. So see guys, all we need to do is 8 divided by the total. That's what probability is, right? Probability of the class divided by the total thing. Okay, so this is very simple guys. We are able to get probability of dear normal. Similarly guys, we are able to get it for all words which occur. Okay, so now we have words, we have probability for each word such that they belong to the normal class. What is our normal class? Normal class is our ham class. Guys, clear? This is very basic. Now the next thing is we need to create a data set for spam messages. Okay, this is for spam messages, that's why it's written in red. Okay, so what you need to do is same way guys, create a frequency count for each word, then compute the probability that they belong to spam class, and compute the other probability that out of the total messages, how many are spam. So out of 12 messages, assume that we had 4 messages which were spam and 8 were ham. So that is why above probability was 8 by 12 and here the probability is 4 by 12. Okay guys, same way we'll compute it guys. See, probability dear that it belongs to spam, same way, 2 divided by the total, that's what is probability, right? Class divided by the total occurrences. So we are doing it. So guys, once we have all this in action, and guys, in Python it's just 2 lines of code. I'm not showing you those type of things because guys, we need to move towards the idea of leveraging LLM. So that is why I'm moving a little fast, but that's very important guys. Now how does this work? So let's say now you have a message which is dear friend, and you wish to classify that as spam or ham. So how would you do it? So first of all, you would compute the probability that it is in the normal thing. Okay, so there are, how would you do it? So first of all, from where this 8 by 12 will come, so you need to do a multiplicative rule over there, which is simple, guys. See, this is very simple. How is this achieved? First of all, probability of normal messages divided by total. Okay, not probability, probability normal message into probability dear given normal into probability friend given normal. Okay, so this is how this thing will get broken down. Probability of normal you have. From where we are getting this 0.47? We are getting this 0.47 from here, guys. Probability of dare given normal, we have 0.47. And from where we are getting this 0.29? We are getting this 0.29 from here. Probability of friend given normal. Okay. So we are able to understand this as well. And same thing you need to do for not normal as well, and then whichever probability is more you will assign that. So see, from where you got this 4 by 12, from 4 by 12 you got it from here. Essentially in the training data we had 4 spam messages out of the total 12 messages. From where you are getting this 0.29? We are getting this 0.29 from here, guys. See, dear spam. The next thing is from where we are getting this 0.14? We are getting it from here, guys. So see, guys, you were able to see how by just using probabilities, and perhaps we are using the idea of leveraging prior probabilities to make computations and decisions. So that's also there. But guys, this is a statistical model, and as I said that now no one uses it. So a basic example which people give is uh, love me and me love. So let's say you receive two things, okay, two messages, one from this. Let's say it's one has this text, love me, and another is me love. So guys, naive bias is actually naive, okay, it's naive. That means that it's not super smart. It would consider these two as equal only. But tell me, guys, are these two equal, love me and me love? So guys, the thing is that you need to understand, I have been saying from the starting of this course that why we need to switch to LLMs is because words have meaning, and until and unless, guys, I don't have an algorithm that will capture this meaning, guys, I won't be able to get great results. If I have an algorithm that can capture meaning inside the words, guys, my system would be very solid. Okay, so that is why we need to start using LLMs and not these type of algorithms. But guys, these are basic things, so you need to know it. As I shown you one classification algorithm on statistical method. Some people use logistic regression as well, guys, but I mean no one now uses logistical regression for NLP. So we'll probably, I'll see if I need to include, I will, otherwise I'll mostly skip it. And guys, the next lecture is very important. So the next lecture would be based on classification metrics. So what are next lecture would be on classification metrics. There you will learn how to evaluate the correctness of a model. And guys, I have given business examples as well, which is very important. So the thing was, I recorded this lecture previously, but for some reasons the audio got recorded, so I'm re-recording it. So that is why. So please guys, subscribe to this YouTube channel. Entire NLP based LLM playlist would be covered. Everything is there. AI engineering playlist is already there, and guys, I'll make sure that all of you become exceptional AI engineers. So thank you guys. Please try to subscribe to my YouTube channel.